So tell me this, Jagnesh, like what do you think when you hear the term big data?
Yeah,
What do you
big
understand?
data is like when we heard the term big data, we are talking about in kind of huge data in some terabytes, petabytes, or zettabytes. So like the nowadays, like if you see any in social networking or if there is any other like even I heard like even for aero flight systems also we receive huge number of petabytes or zettabytes per day. So if you so those kind of huge data when we talk about beta and zettabytes are called as big data, and we are trying to understand what is the and trying to process those uh, big data.
Right, right. You're right. See, I mean, there are different versions to big data. I mean, what you said is one another version, and it
Mm-hmm.
also relevant to the concept of what is big data and all, right? And typically, if you see, there are three different things. You would have heard this in different seminars. That if you go to YouTube, you would actually see only these things,
Mm-hmm.
like let's say like 3 V's, right?
Mm-hmm.
3 V's. By 3 V's, you can say that there is a big data problem, or that is the characteristics of any data, right? Any data, if you classify that under 3 V's, then you can say that is actually a big data problem or a big data. So big data, as you said, it's one thing is volume, right?
Okay.
Volume, as you said, correct. Like the huge data set. Typically, if you have a SQL Server or Oracle, where which is a relational database, you would store data like 1 TB or like 10 TB. Maximum it can go up to that.
Okay.
But what if we have to store data more than that, more than terabyte of data, hundreds of terabyte of data, and petabyte of data? Whether it is feasible in storing in SQL Server or Oracle, and then
Mm-hmm.
do analysis. That is the problem, right? So with respect to volume, if the data, if you have data that is not predictable, that is not of predictable volume. Maybe today it's actually like GBs, and maybe tomorrow it can be in like terabytes. Maximum it can go to like 10 terabyte or something. If you think of it, you can plan on go for traditional databases. That there it's not actually a big data problem because it's actually limited to certain data. The data is not going to grow exponentially and all that is there. But if you have a data which can grow beyond a certain point where it's like 100 terabytes or a petabyte, then you definitely have a big data problem there. So we can say that as a big data by having this attribute volume, which is not restricted to certain numbers.
Mm-hmm.
So volume is one feature, right? Volume is one characteristics. We are
Okay.
talking about like petabyte of data, right? TB of
Okay.
data or 100 terabyte of data, right? Or even beyond that, right? I mean, the data can grow beyond that also.
Mm-hmm.
So you can be able to have how do you solve the problem when it comes to that, right? That's a big data problem, and
Okay.
also something called velocity. So so you have the volume, and then there is another problem to solve now. So I
Speed.
mean, how
Okay.
do you have the data, but storing data is one problem. That is with volume, right? And then
Mm-hmm.
you want to process the data and come out with some business insights, right? And that is something which you would present to the management and say, we're doing this, you can achieve so much profit or sales and all that. And how so you get the data, and how sooner you can actually give this such a prediction or such a forecasting or any kind of activity on the data. What is the latency between the time that you get the data and the time that you actually give the results to the management? That is
Mm-hmm.
again a problem when it comes to huge data set,
I mean,
because
velocity we can say as in the processing time of that
yeah,
data, right? Yeah.
processing time, or the time between you get the data and you process and give the output to the management,
Okay.
are the insights that you give to the management.
Okay.
Okay, so think of also the scenario of training, right, where you
Mm-hmm.
get huge. I mean, what is the latency, or what is the time that is needed to give any suggestion to a customer to buy a specific specific
Mm-hmm.
any product. There you can't expect the latency or the that decision time, the time to take a decision. You can't have a larger decision because you have a huge data set. You can't have the
Mm-hmm.
decision time very longer. You need to respond as immediate as possible. So that is again a constraint when you have huge data set. If you're having simple 1 year of like 6 months of data or like 1 month of data, you want to just predict something, that is easy. But think of data that you are actually having, even you got the data in a day, only for one day you have a data of 1 TB, and you want to predict something, it is also a problem, right? So it is one of the characteristic stuff. So if you have this problem of velocity, where you have to give out your business
So
insights.
1 TB for one day, we cannot predict the data analytics cannot be done, right? So we need to do it for 6 months or 1 year or more than 1 year.
1 year also. Exactly.
Right.
Yeah.
Okay, so
And you need to have, the more
what
the
you're
data.
saying is, in the real-time scenario, there can be situation for 1 day as well. That's what you're saying, right?
No, what I'm saying is, see, your entire system, I mean, it's not like, 1 day, 1 TB. I mean, you have to have huge data. I mean, if the data, when the data size increases, processing the data itself will take some time.
Yeah, that's right.
Right, even if it is 1 TB, or whether you get a one data, whether you get 1 TB in a day, or whether you get a one petabyte in a day, the velocity or the speed, I mean the process time, as you said, right? The process time, where you need to give the business, insight about the data. If the data size is increasing, then again it's a kind of a problem where you can't actually give that, in a day or something. It will definitely latency. So that's what I'm saying. Huh? So latency, basically, they call it as latency, velocity. Latency is something, time between 1 minute. 1 minute.
Okay.
So the time between the data arrival and decision is going to manager based on data. So basically, it involves processing. Okay. So variety, right? I mean, how do you store the data, right? I mean, generally, if you have some structured data, you would know how to store the data and process the data and all. So you have data in a different variety, like you expect data to be in some other format, rather regular row and columnar fashion. So that also gives a problem when you actually have to deal with the processing or to store the data, right?
It can be unstructured data also. I mean, mostly it will be
unstructured. Yeah, I mean, it's not, but it's no mostly, it's not mostly, I would say, predominantly it can be semi-structured data, right? I mean, you can, this problem can come to even structured data too, right? I mean, the large data set, you can actually have huge data set receiving, even it can be structured also. I mean, it can be a row-based, whether you can get from different system. You have Oracle system, you're getting some data from finance, you're getting you have SQL Server.
Structured huge data, right? Those are
huge data. That is also a big data problem only. You can't say that structured always not a big data problem. Okay. Structured or semi-structured. Generally, people assume that it's always unstructured. It's not the case.
Okay.
So
when we see that big data and Hadoop, it's not always unstructured.
Always unstructured. I mean, it's very specially, I mean, if you compare any other solution compared to Hadoop, Hadoop is, when they say Hadoop is more towards unstructured, because you can deal certain structured, huge data in structured data in huge, right? You can actually deal with some other solutions for which you don't have to go for Hadoop.
Okay, got it.
But Hadoop can also handle such a problem. So typically, if you see, there is something called MPP, massively parallel processing databases are available, which can actually solve some of the problems. But I mean, what is the difference between MPP and Hadoop? If someone asks, then they say Hadoop can process unstructured data.
Unstructured data, okay.
Besides structured and semi-structured. So unstructured is mostly like video files, text files, right? Where the text file is like, if you write a comment in Facebook or Twitter, there is no structure to it, but just a text. You can come up with sentiment analysis based on what they have entered. Assuming there is a product is launched and there is a Twitter, the tweets are happening there about the product, and you can take the text and then you can do a sentiment analysis on that. So where the data is not having a structure, it is just the text. You have to get the data, get the words, and then come up with a analysis and all.
Okay.
So it's unstructured and semi-structured. I would say, I mean, it has some structure, but it's not a purely completely structured data. I mean, you can't think it as a like a table. Then will have some structure. You can actually predict. You can actually see the data and come up with a schema. You can say this is actually the field that belongs to this particular category. This is the value of this is the value that actually belongs to this field. This is the value. This belongs to field like customer name.
So some of the data will be structured format and some will be in unstructured or.
Yeah, it will be having some schema. It will be there. It will be there with some schema, but it's not purely tabular.
Okay.
Think of a JSON format, right? This is actually semi-structure.
JSON means like.
JSON. Let me show a JSON format.
XML we would have seen.
Yeah, sample. So this is how it will be. Okay, you see, it will have a kind of.
Okay.
It will have multiple. It can have something like inner structure. You will have glossary title. You have it's like a property key and values. Like key is a title and value is but it is kind of nested. You see, it is nested. From top level, it is actually getting nested. But to some extent, you can understand the structure, right? It is not purely structured, but it is semi-structured. In a way, you can understand the structure of it. So title is S. You're going in some more level of nesting where you have ID and you have some other additional fields and then the values. You can have one field having nesting like 7 levels, 10 levels, 80 levels. Number of levels can go. But how? So this is again a problem, right? This is how actually Twitter stores the data in a JSON format. Okay. So something like that.
So the backend JavaScript is you're saying that is a semi-structured format.
JavaScript. Yeah, this is actually JSON expansion is JavaScript object notation. This is actually one another file format.
Okay.
Just like you think of XML, JSON is another format which is predominantly used in web and all. There are very specific features available which can help in a lot of ways when you actually write a PHP. If you see a PHP, then if you think of getting data from a SQL server and you want to display the information in PHP page where you can actually get the data from a database as a JSON format and display it easily. So there's a specific format like think of binary format or think of text format or XML format. So JSON format can help in a lot of ways. It's very popular in web actually. Very popular in web.
Okay.
So in structured, you can just think of tabular, which is, as I said, you get different data from different data sources. Again, structured, but large in size. So this is how you characterize. This is how you say characterize, something as a big data, and this is how you identify if there is a big data problem in the first place. I mean, some people may say I can deal anything with SQL Server and Oracle. Why I have to go to big data? Then the first question is, see, these are all the 3 things which I would say as a criteria for deciding whether you're having a big data problem, whether you have to go beyond traditional database. So first of all, volume. Do you think SQL Server can handle like 100 TB of data or petabyte of data? If you ask the question, then they will say, okay, yes, I understand that, because now anybody will have a question on that, right? Anybody will have a question why I can't deal the big data with the SQL Server. First of all, the volume is a problem, and then the velocity. With the volume, the processing time will increases, and you can't actually deliver the output or the outcome of any specific data in a faster way. And variety is again a problem where you're not always dealing with structured data. It can be unstructured or semi-structured, right? Or structured data too. So this is something with the big data, okay? So how do you deal with the big data? I mean, Hadoop is the only solution, do you think?
I mean, we do have several other framework coming up along with Hadoop, right? I mean,
yeah, I mean, one would attempt to solve the problem by thinking very simpler way, and then they identify, okay, the simpler approach is not helping, then they will go for something standard ways. And all that is there, right? One simple way I would say is sharding. What is sharding is? Sharding is something like, you see, you have a SQL server. Just think of structured data at this point. You're not worried about unstructured data. You're just thinking about structured data. You're having huge data set. The problem is, if you have a database, the IT will plan for it, right? IT will give a quota and all that. They say, okay, we are giving 1 TB for your organization. So you can ask for like 3 TBs, one for one department. So 1 department for finance, 1 department for HR, 1 department for sales. Okay, I got like 3 TBs. 3 TB each single server instance. But now you solve the problem to some extent, right? Where you had huge data set. By dividing the data set into different department-wise databases, you were able to solve the problem. But the problem is, even if within a department, if the data grows, what happens? Right?
Okay.
Even the HR department can grow beyond 1 TB. Even the sales department can go beyond 1 TB. Then again you get into the problem. So what you can again think of is like, okay, within sales I can create multiple databases, which by year wise, right? By year wise, so I can again come down. I can actually reduce the problem. But the problem is again within a year if the data grows beyond certain size. So all this can come up where you actually, not only this, when you have to combine data from different data sources, when you actually build some data warehouse on the top of it, it actually creates a lot of mess around it. So sorting can be helpful to some extent. When you know the data size cannot grow beyond this. But if the data size goes beyond what you expect, then again it's a problem. So sorting you can limit to some extent.
Okay.
If you have a big data problem, but to some extent you can actually go for sharding, where you can have multiple instances partitioned, or data is split in the different instances based on specific dimension. Like you can go for a department, or you can go for a year. You can have multiple instances. So that is one way of solving a solution, but it's not a complete solution, correct?
Okay. Yeah.
Or you can go for something like NoSQL database. What is NoSQL database? Okay, so SQL database, if I say it's all relational databases. Okay, like SQL Server or Oracle, you can call it as a SQL databases, right? Predominantly it uses SQL, right? So this NoSQL term was actually coined by a person. I don't remember exactly his name. So they were discussing about the problem of big data, where SQL cannot be able to. SQL or relational data table is not able to scale up. So they were conducting a meetup. They were conducting a meetup around the time, and they wanted to give a name to the meetup. So somebody coined the name saying NoSQL, because they are actually conducting a meeting to find out a solution, for a problem which is not solved by any SQL databases or relational database. So they just got the term as NoSQL. There is no specific meaning to it, like just a name. Okay, NoSQL. They just coined the name. So you can also think it like not only SQL. Okay. You should be able to access through any Java code. It should be accessed through any other code, rather SQL. And this is another way of dealing with big data. Okay, so what are all the different? But why we have to go for Hadoop when you have other options like NoSQL, right? NoSQL or specific types. Okay, I mean NoSQL databases are for specific business requirement. You can go for a specific database.
Okay. So based on the business requirement, you are saying we can do this?
Yeah, based on the business requirement or based on the data requirement and storage and all that is there. There is a specific database for specific need.
Okay.
It's not generalized. I mean, you can't store. I mean, there is something called MongoDB, right? MongoDB, have you heard of? MongoDB is document-oriented NoSQL database, where you will store everything as a data as a document. Think of generally in RDBMS, think of transactional databases. Okay, what you do is you will store customer information in a separate table. You would store order information in a separate table, and product information in a separate table, and you will join all that and get the report or something.
That's right. Yeah.
So think of situation in case of MongoDB. What happens is you think of invoice, right? Think of invoice. In invoice, you will have something like customer address, right, at the top, customer information at the top, and then you will have what are the orders they made. What are how many orders and what are the products they bought, and all that information is on one page, right? Something like that. You want to store the information. You want to store one specific document for one customer, where if you retrieve, you should be able to see all the transactions, everything about the customer, anything and everything about the customer in one single document.
Okay.
That is the requirement. Okay, that is a requirement. So I mean, this will help in certain cases where you want to actually see the customer information very fast. think of a very big online store where they have millions of customers, and I mean when you store the customer information, the problem with relation database is when you retrieve some information, it actually do a lot of joins, right?
Yeah,
It
a
has
lot
to
of
do
joins.
orders, and joins actually
Yeah.
makes performance very slower. And when it comes to millions of information you want to store, like huge data set you want to store, joins are actually a very big bottleneck.
Yeah.
So with the NoSQL databases like MongoDB, if you store another information and you index the information by specific key, for example, customer ID, you can get the information very faster.
Okay.
There is no join possible. There is no way you can join with NoSQL. Joins doesn't work there. Okay. So anything and everything.
But still, we will be writing some SQL queries, right? In Mongo, I mean, any NoSQL.
Yeah, there are options actually. There are options we can write SQL, but generally they will access that through JavaScript. MapReduce, JavaScript and all.
Okay. MapReduce programs. Okay.
MapReduce program is a specific style of reading data in distributed environment. Reading data in such cases.
So NoSQL database also, I mean, DBs, I mean, to access, we use JavaScript to access NoSQL database, right?
Yeah, you can use JavaScript. You can have an API layer. You can have Java even write the data. Recently, you have something like Spark. Spark is something which can work in NoSQL databases. There are some connectors available. Like you can actually access one tool. I mean, from SQL, there is something. Spark has come up with something called Spark SQL. So you can connect actually MongoDB through Spark SQL and write a code, retrieve the data from MongoDB. Or there is something called when it comes to Hadoop, there is something called Hive, which is a SQL layer.
Yeah, Pig and Hive.
Right? There is a connector available that you can actually connect to MongoDB and get the data. So there are different interfaces available.
Okay. So
generally,
NoSQL database is Hive. Hive is a NoSQL database, right?
No. HBase is a NoSQL database when it comes to it.
HBase is a NoSQL database, right? Okay.
There are different types of NoSQL databases. They have like a key, a key based. There's something called columnar based. This is complete document based. See, if you see the types, these are all different types.
Okay.
Graph based. These are all a specific requirement of data or how you want to store data. This is not general format. You can actually use the document database in some other format, right? You can, if you think of document database, which is MongoDB, which is special purpose, right? You want to store the data in a different way and retrieve the data in a different way. Store and retrieve in a different way compared to traditional databases. So you want to store anything and everything as a document. So there is a specific kind of requirement.
Okay, so for Cassandra, where exactly it will come? Cassandra database?
Cassandra will come in columnar. Cassandra HBase.
And there's a Couch database, right? CouchDB.
I think Couch comes under key based, I guess. DynamoDB. I need to check that. Okay. DynamoDB and all. Couch also comes under key based, I guess, but I need to check that. So Graph, you will have Neo4j. Okay, so I mean, what the problem with the NoSQL database, as I said, it's a specific kind of a specific type of information you want to store. It's not a very general purpose. Okay. So that is so. But you want to have a generalized approach. You want to have more general approach in a way. The data document can be of any type, right? In case of RAT.
Yeah.
It can be of any type. It can be structured or unstructured, or it can be of any type, and you want to store it. You want to store it in a. You just want to dump it. You just want to dump it in, and also whatever volume it is, you want to just dump it, and later you want to decide on, parsing the information. So that is the difference between Hadoop and NoSQL. Okay, so as I said, NoSQL is very specific type. With Hadoop, it is not. There is no specific type. Like, but you can only store the data in a specific way, like a column oriented or cube oriented, or you want to store it in a document, right? That all there with NoSQL. If your problem can be solved with NoSQL, okay, you can stop there. You don't have to come to at all. If your problem can be solved with sharding, you don't have to come to any other solution, right? You don't have to think of any other solution. So Hadoop is something beyond these points.
Okay.
Your problem is more general. I mean, right? Some of the data you want to store it in a different way. Some of the data you want to store it in a different way. Where if you're going for MongoDB, that alone cannot solve your problem, then you will go for Hadoop kind of a solution. Because it's a more general kind of approach.
Sometimes there can be combination of approaches, right? Sharding, NoSQL.
Possible. Exactly. You can go for. I mean, it depends on the business requirement, right? You can
business
actually have
requirement, right?
NoSQL and also Hadoop in two places. Okay.
Okay, okay.
Not it's not a, this is you have also something called MPP.
Mm-hmm.
So it is massively parallel pair processing databases. Have you heard of Green Plum or Vertica?
No.
See, these are alternative to OLTP databases. So you know OLTP, right? I mean,
OLTP
your
we know,
data,
yeah.
you know, right?
Yeah.
OLTP and what is OL? See, you will have OLTP and OLAP. No, sorry,
Yeah.
I should be saying OLAP rather OLTP. So OLTP is like a transaction database, and you have something like a OLAP. OLAP is actually analytical database. What they do is from an OLTP database, they take the data and then they move it to OLAP databases, which is like a data warehouse, right? So
Mm-hmm.
so that way, you know, you can use the OLAP database for advanced analytics and all, because that way you will not interact with the OLTP databases, which are in live, right? Which are live,
Mm-hmm.
which is basically a transactional database, which you will not touch at all. I mean,
Okay.
for external users, only for the customer. When customer places an order, that information will be stored in OLTP, and you
Mm-hmm.
want to analyze whatever data you collected in OLTP. So you move the data from OLTP to OLAP systems,
Okay.
and then you will build a data warehouse kind of environment, and where you would actually analyze the data. Okay, but the
Okay.
problem is there. What the problem you find there is, even with the OLAP, uh, the data set is huge, the data set
Mm-hmm.
is huge, you will not be able to analyze the data. I mean, in OLAP, if you see, they will have something like a star schema, snowflake schema. They actually completely denormalize the data,
Mm-hmm.
and so that you can actually analyze the data by dimension, by specific dimension, by specific time period, and all that is
Mm-hmm.
possible. Faster retrieval, and you can analyze
Okay.
the data quickly. But when the data size again increases, there again it is again a problem there, and moreover, there
Mm-hmm.
will be a lot of latency. Latency in the sense you need to wait for a day
Mm-hmm.
or more than a day. They actually freeze the business, like they actually freeze the data, ETL process like 15 days once, and all that is there. So there will be
Mm-hmm.
because of different constraints they have. So MPP is something, what you can think of it as like, something like a data warehouse environment where you have the data is denormalized, very good for analysis, but the uh, uh, data is actually stored in a very optimal way for analyzing huge data set. Huge data
Mm-hmm.
set. Again, it's structured data. You have a
Okay.
huge structured data, but you want to analyze the data with just SQL
Mm-hmm.
kind of stuff. But and at the same time, it should be very fast, right? I mean,
Okay.
just think
Okay.
of Facebook, right? Think of Facebook or Twitter. They have
Mm-hmm.
this customer information, customer interaction information. They want to store the information in somewhere, and they just want to process. They do want to join with a different database content, and then they just want to process the data and come up with some metrics that they can use to add advertisement to the customer pages and all. So
Okay.
think of a scenario like that, right? I mean, you need to actually dump the data, very huge data, structured data, and then you want to process that immediately and give the results.
Mm-hmm.
Okay, the
Okay.
process. I mean, this MPP, or they call it as you know uh, MPP databases. When you think of Vertica or Greenplum, they call it as high speed processing, SQL based. Okay, they also call this as a kind of in database analytics. What is in database analytics is like, you did put the data into
Mm-hmm.
these vertical or Greenplum databases, and then they have lot of analytical functions in integrated with SQL. Okay,
Okay.
so you can do the analysis there itself. You don't have to move the data to somewhere else and do analysis.
Okay. Okay.
Completely SQL, and it is very faster. And as I said, it's more structured. It's best suited for structured data. So again, if you see, MPP it's not solving all the problems, but it's solving one problem there. Correct?
Kind
Just
kind of
no
structured
SQL.
format it is solving it.
Yeah, it's only structured format. to some extent it can support like JSON format, but not all other format if you think of. Unstructured format, no support.
So all the data analytics tools, I mean, most of the data analytics tools will be is Vertica and Greenplum only. They are using this.
Yeah, I mean, in large scale. They want to do analysis of huge data set.
Okay.
Huge structured data set. They actually go for MPP. Rather, they don't go for data warehouse. They won't want to build this data warehouse, but they will go for MPP. Again, this when I say NoSQL database or sharding or MPP, all this solves a single problem. One or the other single problem. It's not actually solved. Not a one place for solving everything, right?
Yeah, that's right. So as a part of Hadoop developer, so we should be in a position to choose what is the exact solution, and also we should be in a position to understand the MPP things, right?
It's better to know, right? I mean, when you are in a meeting, when they say, why not we go for Hadoop? I mean, generally, if you're a Hadoop developer, you would have Hadoop infrastructure already built in.
Yeah, that's what. So as a part of Hadoop developer, so the solution for the particular requirement has already been found out that it can be resolved only by Hadoop, right?
Yeah, you would have passed all this, right?
Yeah.
You would have passed all this.
Probably the Hadoop architecture, or from architecture point of view, probably they would be.
You need to know.
Yeah.
You need to know. They may say there are cases where you can integrate Hadoop and MPP. There are cases where when you have to integrate Hadoop and NoSQL, then you need to know what is NoSQL, right? Then you need to know what is MPP.
Correct. That's right. Yeah.
So you know to some extent what is MPP or what is NoSQL, even if it is not very detailed, but you got an idea, right?
Yeah, that's right. Yes, Raj.
You will further develop on that when it comes. Yeah. When the time comes. Okay. So Hadoop is, when I say Hadoop is, moreover in case of MPP, right? I mean, if you think of Vertica, Greenplum, it's all proprietary. In a way, we have to pay for the software. It's not open source.
Okay. It's not open source.
Not open source.
Okay.
You have to pay for the software. For one node, if you're using the software installing in one node, or the database, if you're installing the database in one node, you have to pay per node.
Okay. How about the NoSQL database?
NoSQL database, some of the databases are open. I mean, they call anything as open source, but when it comes to service and support, we have to pay for it.
Okay. And
moreover, as I said, right, if you go for MongoDB, you can go for something else. There may be a vendor locking.
Okay.
So, but when it comes to Hadoop, it's completely open source.
Okay.
So now you are in a position that
for one particular client, they'll be having like either MongoDB or Cassandra or something like that, right? They have some specific.
A client can have based on their business requirement, right? They think that their data problem is something like, in case of HBase or Cassandra, right? Don't think of HBase now. Just think of Cassandra. And I think of Cassandra is good for storing time-based data. I mean, you want to store for every second in a day. What is the status? What is the metrics? You want to store different metrics for every second. For a machine, right? If there is a machine of the server, if it is giving, if you want to store the certain metrics of the machine, like how much CPU is used, how much RAM is used, how many CPU cycles are running, and all that you want to store per second, so that you will know at what time it actually goes like a very high peak time, or based on that you can compute whether the server can fail and all that. Okay. So you want to store per second in a day all the information, all the metrics. In such cases, you can go for Cassandra. Okay. So see, there is a specific requirement of storing the data, right? There's a specific requirement on what you are going to deal with. So I mean, so that's the case. I mean, it can solve one kind of problem. So if a client think that they have one kind of problem and that can be solved with Cassandra, they will go with Cassandra. That's all.
Okay.
Moreover, Cassandra is something which can store the data across data centers. You can have a data center in the US in different places. You can have it in California, you can have it in New York, and different places. Okay, and if any data center fails because of the hurricane or any other natural disaster,
that is how the distributed file system will work, right? So I mean, even the HBase also does the same thing.
No, but it's not data across data centers.
Oh, okay.
Okay, Cassandra across data centers.
Across data centers, in the sense it is. HBase is also like a distributed database.
Distributed, but it is a distributed database which is based on Hadoop. Hadoop is actually distributed file system. Okay. So when you will have a rack, Rack
Yeah, yeah.
server will have multiple, but that will be one. I mean, you will have multiple racks. I mean, one rack will
Okay.
have 50 machine or 20 machine, and another rack will have 150 or 20 machine, which is under only under one data center. It will not be under different data centers. At this point, there is no implementation of Hadoop across data centers.
Okay, okay. But that is for Cassandra across data centers.
Data
Okay,
center
okay.
is possible. That is main. That's
Oh,
what the
so that
main
is
thing.
in that case, it is that much huge, right? When compared to H-based, Cassandra is very.
Yeah, it has more scale, more. I mean, very mission critical data if you want to have, where you're really worried about, data availability, right?
Okay,
And you
okay,
want
got it.
they go and go for Cassandra. So now you see that there are different ways of solving big data, but with a different kind of problem you can solve with the
Solutions.
big data. Yeah, solutions, different kinds for different needs, right?
Okay.
Hadoop is something which is towards the end. I mean, and I would say after you see all that, okay, after you see the sharding problem or sharding way of solving problem, after you see NoSQL, PP, finally you come to a stage, okay, now I want to try with the Hadoop. So majorly, it would be a last step.
Okay.
Okay, or you can think based on based on the business scenario, based on the data requirement, analysis requirement, and all that, you can plan whether to go for Hadoop or go for any other systems solutions. Okay, so Hadoop,
Okay.
as in this, so Hadoop, what all the features compared to other things, right? I mean, it's open source.
Yeah.
So that's the one beauty, because if you think Hadoop was introduced around 2002, I guess, but the first commercial release happened around 2009. When I say 2002, it is actually, they got the white paper. I mean,
Okay.
see the problem. If you see the problem where Hadoop actually, came to the picture is is with the Google. Okay, Google was the
Okay.
uh, first company to use something like a distributed file system for
Okay.
their problem. I mean, if you think of days around 2004 or 2002, right? I mean, where
Yeah.
the internet is booming, where people
Yeah.
go to
Yeah.
browse center and they search, right? So the problem with Google, the problem what Google faced was they have to, when the user types some string there in the Google search page, it has to search through all the web pages available. Okay, and then it has to do a page ranking algorithm to run, and after that it has to give you relevant top 10 pages. Correct? That's
Correct.
what it shows. So first part is first to store all the data, all the web files data,
Yeah.
all the web file data, and then second problem is to run a batch oriented job and come up with the page ranking, and then index that result based on the search keyword, right? Behind the scene, what happens is if people are searching something, right, and if it is there already if it is already indexed, then it can give you the top 10 pages faster. If it is new,
Okay.
then it may take some time, right? Or
Okay.
it may not be relevant at this point initially. So if behind the scene, what they do is they actually go through all the the code actually go through for a given keyword. It actually goes through all the web pages, and then runs a page ranking algorithm and come up with the top 10 pages for a given string. For example, if you are saying Hadoop, then the top 10 pages will be indexed for the key,
Okay.
for the string. Okay, so when you actually type Hadoop, then you will get the top 10 pages, which is actually indexed and kept it somewhere, so you will be able to retrieve it faster, because
Okay.
running
Okay. So it's
page
not a new
ranking
search. It is already been the search is already been
yeah,
done, and
indexed.
it's already indexed, and so we are getting that one faster. Okay.
Yeah, I mean, it may be, I'm not sure how frequently they run this indexing process. It may be
Okay.
refreshed. It
Okay.
needs to be refreshed, right, every day.
Yeah.
Otherwise,
Yeah.
you may get old links only. But this is
Okay.
something which
Okay.
keep on running, keep on happening in the back end. So there are two problems they were facing. One problem is to store the data of web files and or the files that are indexed information and all that is right, because there are millions of searches happening
Records.
and
Yeah.
millions of indexed information needs to be stored somewhere,
Yes.
right? And the file also needs to be stored. So storage is a big problem for them. So they want to come up. They were using initially MySQL. They are having MySQL cluster, like multiple MySQL instances, but they were not able to come up with a solution. Then they come up with something called distributed file system. Okay, distributed file system. They want to store the information or the file or the store the data in different machines and a framework that takes care of which data is stored where, and when you retrieve the data comes without any problem, and also in case if any specific node fails, some other node helps there. So all that combined together as a distributed file system, they come up with. Okay. And when you have a data, so now the problem is solved when you store the data. But when you actually want to run the page ranking algorithm, and you want to do an index or specific index information, then they have to go for some processing method. So they come up with something called MapReduce. Okay, so these two are the white papers that they submitted around the time of 2002. Okay. So MapReduce is one white paper, and distributed file system is another distributed file system. They based on MapReduce. These are the white papers they submitted, and what happened was that time with Google, there is a person called Doug Cutting. Doug Cutting is a person who was working in this project. Okay, so this guy left Google. Okay, he left Google and he joined Yahoo. And what Yahoo did was, Yahoo and then Doug Cutting, they come up with something like HDFS and MapReduce, which is nothing but a very similar version. Based on the white paper that Google has submitted, they were able to come up with something like a Hadoop file system and then MapReduce. They call this as a Hadoop, right? So Hadoop is a framework which comprises of two things. One is HDFS, another is MapReduce. HDFS is for storage, MapReduce is for processing. Okay. So then what the Yahoo did was they actually open sourced it. Okay. See, it is proprietary when it was with Google, and they only submitted the white paper. And Yahoo, and Doug Cutting, they come up with something like HDFS and MapReduce. I mean, working version. Right, it's not white paper. It's again working version, but they open sourced it. I mean, that is the very best part of it, because when you open source something, people will try to use it because they don't have to pay anything. Correct. Then there were after Google, right? You can think of some companies which are very good in which were dealing with huge data set. Right? What companies you can think of? You can think of Facebook and Twitter, right? Yeah. Twitter and companies that started after the internet boom, right? Correct. I mean, so they were trying to use these features. I mean, they were trying to use this framework for their problem. Okay. And that's how it started actually. So because it's open source, other companies are able to come and take the code and they try in their business problem whether it can solve the problem, and they were trying it actually. So that's how it became a popular. And around 2009, the first commercial release was done. Commercial release was done by Cloudera. See, Cloudera is a company. What they do is they take the open source, open source software, and then they build their own tool. They add their own tool also, and then they package it to you. So you have to only pay for the service or the support. You don't have to pay for the software because the software is open source. And if they give you software additionally, then you have to pay for that also. For example, if they give in Cloudera, they give cluster management tool. I mean, cluster management tool is if you have a cluster of 100 machines, if you want to manage that with the software, they can also give you some additional software for which you have to pay. Other than that, whichever the open source software which they are providing to you, you don't have to pay for that. Okay. So that is the very first commercial release of Cloudera around the time of 2009.
Hadoop or Apache Hadoop both are same, right?
Apache Hadoop, yeah. I mean, when I say open sourced, right? When Yahoo open sourced it, they open sourced it in a platform called Apache Software Foundation. Okay. To them, they open sourced it. So it's actually a foundation which actually deals with the open source stack, and any developer can actually join foundation and they can actually take the code and then contribute back, and all that is possible. You can also do where people can also do the donation for the software foundation. All that is there. So because it is open source to Apache Software Foundation, anything and everything under Apache is called as Apache Hadoop, Apache, Apache. You see the name appended to all the tools that are there as open source. Hmm.
Okay.
So you got it, right? I mean, so far you were able to understand
Yeah.
what is,
Yeah, I could
huh?
understand. Yeah.
Right? So commercial release was Cloudera. So after Cloudera, if you see, there are other vendors, other distributors has come up. You have something like Cottonworks,
Mm-hmm.
and then you have something called Mapper. So what they do is they actually very similar to what Cloudera does. They actually package the open source tool and then they sell it with the service and support associated and additional softwares.
Mm-hmm.
Okay,
Okay.
so I mean, now if you see the leaders, Mapper is leading the industry to some extent because it has a very robust structure, very robust
Mm-hmm.
tools and service and all that. And Hortonworks is
Mm-hmm.
next, and Cloudera is also there in there. But I mean,
Okay.
if you see, Mapper has a very good implementation because the thing is,
Mm-hmm.
Mapper, the Mapper implementation of Hadoop is entirely different from even the open source Hadoop implementation.
Oh,
They
okay.
have very specific. They have. They don't call HDFS as HDFS. They call it as Mapper HDFS. So they even HDFS here in other cases is open source, but in case of Mapper it is not open source. I mean it's proprietary to some extent because the way they handle the data. I
Mm-hmm.
mean the way Hadoop framework is structured in Mapper is different. I will come to that little later, but for now it's
Okay.
little so early to guide you. But definitely towards the end I will guide you on what are the differences between these
So
distributors.
Hadoop developer should be in a position to, I mean, know
Yeah,
how
yeah,
the mapper
yeah. Mapper is different
and
from
commercial
Cottonworks.
Cloudera and Hortonworks.
Yeah,
Yeah.
yeah. It's
Yeah.
just Cloudera, not it's commercial release, I would say. So Cloudera, when you say of Cloudera, okay, not commercial
Mm-hmm.
Cloudera. It's Cloudera,
Okay.
Hortonworks, and then Mapper. So you need to
So
know.
the
I mean,
so the interviewer, I mean, like just talking about interview perspective. So basically, the company is having mapper, then they will look for mapper developer, Hadoop, who has the experience and
not like that. I mean, I mean, Mapper may have some specific constraints, but generally, if you know one specific distribution, it's all using Hadoop only,
it's all
right?
interrelated, right? So there is no specific
Specific, no.
from
They
the
may
interview
ask.
perspective,
I
right? They
mean,
will not restrict,
they
right?
definitely will ask. You can say I was using vanilla versions.
Mm-hmm.
I mean, generally, you can say like, if I was using open source version in my company, you can't say that to some extent
Mm-hmm.
because most of the companies are adapting one or the other distributors at this point.
Okay, okay,
So you have to at
okay,
least say, Cloudera. I worked
okay,
in
okay,
Cloudera.
okay,
So when
got
you
it.
say Cloudera, then you may need to know a little bit on what are all the additional tools they have. They have something called Impala. So they may ask you a question on what is Impala, so that they will
Mm-hmm.
understand that whether you worked in Cloudera or not. So
Exactly.
some of these when you say Autonox, they may ask something specific to Autonox
Something,
specific.
yeah, specific. Okay. Correct.
You definitely have
So at
all
least we should
general
know
things
the
to.
name on the functionality and what exactly it does each and
Exactly.
every.
So for
Yeah.
you, I would suggest you go with Cloudera because with the training also we will go with only train Cloudera.
Okay. Okay.